we are going to do derivations of magnetic field due to current in a straight wire, due to current to an arc, and current in a circular loop. Before that, we will see some important formulae. Magnetic force acting on charge q moving with velocity v. Just a charge q. Vector form f q v cross b. Then magnitude, if we solve the cross product, we get vb sin theta. So f is q vb sin theta. So the magnetic force acting on a charge q is q vb sin theta. Now if we consider current carrying conductor having current I, then the force acting on it is F equals to I L cross B vector form, that is magnitude form, it is BIL sin theta, where theta is the angle between the vector B, that is the magnetic field, direction of magnetic field, and the length. Then the Biot-Savart law is for a current element. So there is a wire carrying current I, a small element dl. We have to find the magnetic field due to this element dl. So we denote it by dB. This point is at a distance of r. Then dB is mu naught by 4 pi idl. Biot-Savart law first tells you that it is proportional to the current, it is proportional to the current element, inversely proportional to the square of distance. And then the constant comes mu naught by 4 pi. So, combination we get dB is mu naught by 4 pi I dl sin theta by r square. Then we write it in vector form, in the cross product form. So, as there is sin theta, we will write dl cross r. Because we have now taken r in the numerator, here it becomes r cube. See the difference? R cube we have taken because we have taken r in the numerator to write in the form of vector form. So this is Biot-Savart law. This is very important in all the derivations that we are going to do. This theta is the angle between this. So if you draw a tangent to this, then the angle between this, that is theta. So we are going to do derivation magnetic field due to current in a long straight wire, infinitely long straight wire. So this is a long straight wire. We are considering an element dl. It is carrying current I. This is a point P at which we are going to determine the magnetic field. And this is r distance, small r is the distance between dl and the point P, and perpendicular distance is capital R. We will mark this angle as theta. Now first we will apply again Biot-Savart law. Okay. So according to Biot-Savart law, dB is equal to mu naught by 4 pi I dl sin theta by r square. Where you know mu naught is permeability of free space or air or vacuum also you can say, and its value is mu naught equals to 4 pi into 10 raised to minus 7 Tesla meter per ampere is the unit. You can just see from the formula, this is Tesla, this will be meter, I is ampere. So Tesla meter per ampere. Now what we are going to do, we have to find the magnetic field at point P due to this long wire. So we will consider two halves, the upper half and lower half. So the magnetic field B, the total magnetic field, this is just the magnetic field due to the current element. Total magnetic field is 2 into, we have to integrate 0 to infinity. It is a long, infinitely long straight wire, dB. So now we substitute dB. Now, you can just see this. We'll have to consider this much length as L of the wire. So, we have a relation, small r square is L square plus capital R square. And one more thing, now this angle is pi minus theta. We can again consider this triangle and use trigonometry. So sin pi minus theta we will find. is opposite by hypotenuse, so that is capital R by small r. But sine pi minus theta is sine theta, so sine theta is R by small r. But again we know small r is under root of this, so you get R upon under root L square plus R square. So now we will substitute both this R square and sine theta in that formula. So we have B equals to 2. I will take mu naught by 4 pi out 0 to infinity I dl sine theta we will write as this, and R square. Okay, so we have substituted sine theta and we have substituted the small r square, which is capital R square plus L square. So we get in the denominator R square plus L square, capital R square plus L square raised to 3 by 2. All other terms, that is mu naught by this becomes 2 pi. I and R are taken out of the integration being constant. Now this integration can be solved by substituting L as R tan theta, but in the derivation you need not show that, you can directly write the answer. So that comes to be, if you want you can do and just see whether you get the answer. You have to just substitute L as R tan theta, substitution method. Okay, then the limits also change, and that gives you 1 by R square. So the formula is mu naught I by 2 pi R. So this is the magnetic field due to a long, infinitely long current carrying straight wire. Next derivation is magnetic field produced by current in a circular arc of wire. Now this is a circular arc. This is a wire AB carrying current I. We are considering the small element dl. We have to find the magnetic field at this point P. This is carrying current I. So again we are going to start with the Biot-Savart law, that is the magnetic field due to this current element dl. Now in this case the direction between the dl and this r, that is 90 degree. Okay, so here when we use the Biot-Savart law, that sine theta that will come sine 90. So first we'll apply Biot-Savart law. dB is equal to mu naught by 4 pi I dl. I'm going to write directly sine 90 because theta we have taken something else here, upon R square. Sine 90 is 1, so you get mu naught by 4 pi I dl by R square. This is dB, that is just due to this current element. Now if you want to find the total magnetic field, what we do is we integrate from where to where. This is not infinitely long, from A to B. Okay, so that we considered in the plane 0 to theta. So total magnetic field is 0 to theta dB. So mu naught by 4 pi, again I take out 0 to theta I dl by R square. Even I by R square you can take out of integration sign. So mu naught by 4 pi I by R square integral dl from 0 to theta. Now in this integration, mu naught by 4 pi I by R square I have taken out. In the integration remains dl. Now we are going to use the basic formula in physics for an arc. If you have this theta, this is r, then we have the formula that dl is equal to r theta, r d theta. So we will substitute dl as r d theta. R also you can take out of integration. So we have this. Then integral d theta from 0 to theta we will get theta. So this is the formula for a circular arc when we know that angle. Now from this we can even find the magnetic field at the center of a circular wire. So magnetic field at the center of, so if the derivation is asked for the magnetic field at the center of the circular, you will have to first consider an arc and then center of circular wire or conductor. That time theta is 2 pi. So we can substitute theta as 2 pi. So we get magnitude of magnetic field as mu naught I by 2r. Next derivation is magnetic field produced by current in a circular loop. So we have considered a circular loop in the 3D x, y, z. Then it is having the radius capital R. It is carrying current I. Now this is a point P, and at this point dB is the magnetic field due to the current element dl. Now again we will use Biot-Savart law and then write the formula for the magnitude for dB. So dB is mu naught by 4 pi IDL, that is sin 90 here again, by R square, that is mu naught by 4 pi IDL by R square. Now here what happens is dB is resolved into two components, dB perpendicular and the horizontal component dBz. Now if you also see this side of dl element, and if you also resolve that this way, dB perpendicular dBz, so the perpendicular components will cancel because they are opposite. So only dBz will retain. So after this we will write down dB is resolved into two components, dBz and dB perpendicular. But due to symmetry, you can see if you have dl element on the other side exactly, you will have dB perpendicular this side and dBz along the same. So dBz component gets cancelled, dBz component remains or retains. So see, what we have done is, by using Biot-Savart law, first we have written the magnitude of dB, mu naught by 4 pi IDL by R square. Now this dB is resolved into two components, where now dB perpendicular component will get cancelled and dBz component survives. So now what is dBz? It is the horizontal component, cos theta component. So dBz is dB cos theta. So you just see the triangle, cos theta is capital R by R. The small r we can write under root z square plus r square. Now you know what is cos theta. dB also we know by Biot-Savart law. Both we will substitute here. So dBz is equal to mu naught by 4 pi IDL by R square into capital R by under root z square plus r square. And again r square, here also we can write r square as z square plus capital R square. So denominator we can simplify the small r square. You know that is small r square is capital R square plus z square. This we already got root. So this will become in the denominator 3 raised to 3 by 2. Which is this dB. Now we will integrate it to find the total magnitude of magnetic field. So I will take the components which are constant out of the integration. Only remaining will be R. Only remaining will be just dl. Integral dl means we add all, we take the summation of all the dl elements along that circular loop, so which is nothing but the circumference 2 pi r. So finally we get the formula, pi and 2 will get cancelled.